All right, welcome to our final session of the day where it's a Q&A free for all. Let's I'll give a couple more minutes to for people to sort of file into this link here. And then we'll get started with some questions. If you did post a question in the last Zoom, I saw it and something about I thought none of it, and then then we ended the Zoom meeting and whew, it all went away. So feel free to ask that question again if you if I didn't get to it. Okay. You are. Thanks, William. I appreciate it. I'll start with that question and then just to sort of close that, and then we'll sort of dive into some other questions. And as a reminder, take a minute to submit your questions using the Q&A in Whova. That is the best way for us to see them, and we'll just start selecting questions and answering as we go. So don't be shy. And this is an excellent opportunity because you got the eyes and ears of some great some very well-known experts, best top of the line here. So yeah, submit your questions now and we'll get to them. So from the exercise earlier that we thought that we just finished, the question is, I thought nonlinear constraints had to be in the form of y equals f of x. And if I say anything incorrectly, let me know, but that was Gurobi 11. You had to do it that way. Now there's a little bit more um, uh, flexibility in how you can model these things as well. Is that the correct way of answering that?
I can jump in on this one. So
Yeah.
basically, actually, so with the nonlinear expressions, this NL expression type, we need to formulate things in that way, like a single variable equals a nonlinear expression. But I think in the exercise, maybe there was a quadratic expression, and I think for those we have a little more flexibility, or for also for linear expressions, how we can put things together, and Gurobi will automatically rearrange and simplify those.
Okay, awesome. So, first question is let me move some stuff around. There we go. Um, do we have any examples for power system optimization? Um, the world is focused on net zero and want to include more and more renewables, keeping reliability and stability of power systems as a preference. So any examples, anything that we'd like to talk about regarding that topic?
Yeah, I can jump in. So, I think in for power systems, I mean, optimization has been used for a long time for a lot of decision making. One of the classical problems is the unit commitment problem, which is basically looking at like how do you optimize when you should say turn on and off your generators at your various power plants. But with renewable energy and smart grid and a lot of the new developments, a lot of the decision making around the power grid have become a lot more complicated. So, for example, whereas in the past, decades ago, you might have pretty good predictions for each day about like what the demand curve of energy across the day would be. And you could plan ahead about when you would turn on and off your generators and how you would, transmit that electricity through the grid. And then now, I think with people having solar power, for example, if the sun comes out and then gets covered up by a cloud, that can affect that can impact like locally what's happening with the demand. Also, if you're generating wind power or solar power, as a producer of energy, that's the weather can dramatically impact over short periods of time the amount of energy that's generated. So for all these things, it leads to more sort of complicated systems that involve more demand in making decisions.
Awesome. Uh, that's I think yeah, that's a pretty thorough explanation there. Thanks Dan. So let's see. Another question is in mixed interlinear programming. does changing the sequence of data or constraints impact the solving time and MIP gap convergence rate? It's possible that some sequences lead to faster improvements than others. Are there any strategies or guidelines that we can use to determine like what that sequence should be for for constraints or data pre-processing steps to get quicker convergence or lower solve times? So essentially, is there anything any best practices with regards to that? Or is it even a significant issue in your experience?
Right. I guess I'll chime in again on this. So yeah, this is actually a well-known phenomenon that if you have a model for like integer programming, if you just take the constraints and the variables and you sort of permute the order in which they're added to the model, this can change the sort of solution path that's taken. And in some cases, this can dramatically affect the solution time. I mean, it really varies from problem to problem, how sensitive this is. It basically say the simplex method might start taking a different path along the polyhedron because it's sort of shaped differently. And then you might get lucky in one case and unlucky in another where you just happen to land at a, you know, LP solution where a heuristic just finds the optimal solution early on. And then in another case, it doesn't. So a lot of this, I think sometimes just induces some randomness, that there's this kind of performance variability. And I'm not sure that there's any particular strategy we could recommend about what order to put, because a lot of times it ends up just being arbitrary. Gurobi internally will, do factorizations of matrices and other reordering of matrices as it does its algorithms. And so it will already be trying to be smart about how to reorder things to do some of the linear algebra.
Okay. So the so essentially it's just hope for the best in a sense.
Mhm.
Let's see. Next question is, how would you identify and differentiate situation variables from decision variables in nonlinear programming models? And what impact could misclassifying a situation variable as a decision variable have on optimization results?
Yes,
Any,
I'm
yeah.
not sure what's meant by a situation variable.
I think that may mean something like essentially a parameter in so something that can be like a fixed value in a certain scenario.
Hmm.
If you submitted that question, maybe give a little bit more of a um, clarification there of what you mean by situation variables versus decision variables. So we'll put a pin in that one.
Yeah, and I'll just mention a related thing. I mean, sometimes as we're formulating models, we might have some decision variables that are corresponding to our actual, end decisions. And then there's some other variables that are like some auxiliary variables that we create as part of the model internally,
Mhm.
or part of the formulation. And I think for those, we're not specifying any distinction between those. So I don't know that that would have an effect, but maybe something different is meant here.
Gotcha. Okay. So in the last um, notebook, we sort of saw that uh, quote with the asterisk thing in the summation, and sort of said that that's a quick way to sum over a particular index. Um, is that is that does that behave like the same in SQL, where you use the asterisk for that? Um, I don't know. Hassan, if you wanna, if you're, are you a SQL expert?
No, but I think what they're asking is if the asterisk here in Gurobi is
Mhm.
similar to when you're using in SQL to select all. And the answer is yes, right? Essentially, it's a wildcard. And when you are having the summation, for example, if you have xij and you have x dot sum, then that wildcard asterisk j, it means you're summing over all the i's. So essentially, the answer is yes. It is kind of behaving in a similar fashion.
Cool. Let's see. Next question is it advisable to use a piecewise linear function to linearize nonlinear objective and then solve it as an LP or MIP problem. So I think, Hassan, if you want to sort of jump in on that, on when that would be, are there things that you would look for that, or what would be the decisions that you'd be, the criteria that you would be considering to make a decision on linearizing and using piecewise linear or just sort of using nonlinear directly?
Yeah, I would say before Gurobi 12, I would have definitely gone with linearizing it, maybe even trying to see if it is possible to reformulate or going with something like the piecewise linear approximation. But now that there is Gurobi 12, I still consider it as one of those things that we need to test, right? Because it totally depends on the nature of that nonlinearity. Because if there are it's a very acute nonlinear. There's so much, as Dan explained in his talk, there are lots of valleys, and in those cases, maybe I would go try both. Maybe with a lot of segments in nonlinear approximation, actually the solver needs to take more time. So in this case, it's one of those that I would say you need to try both, right? So try going with the piecewise linear, going with nonlinear, and maybe actually you prefer, again, as long as that exists in the solver, right? The function exists in the solver, you can go with that, and see if the performance is something that it's satisfactory to you. You don't need to go any further. Otherwise, you can try another approach. Did I miss anything, Dan, that you want to chime in?
Yeah, I agree. I mean, I think in some cases you may try both ways. When you use a piecewise linear approximation up front, you're sort of giving a static approximation that it has some. It's not a fully accurate approximation. There's some errors, and depending on the shape of your nonlinear function, those you might need a lot of pieces to get an accurate representation. If you're modeling it as a nonlinear function, Gurobi is actually internally going to be using linear inequalities to sort of, for most cases, to give an outer approximation of the nonlinear function that it will be sort of iteratively refining and getting more and more accurate sort of linear outer approximations. And it does this in a dynamic way, so it's able to sort of drill down and get really good approximations of those nonlinear functions right where it counts. So this is very effective. So I think in most cases would recommend trying the nonlinear functionality, but in some cases, piecewise linear is something you can try, especially if you're willing to live with whatever kind of inaccuracy you get from that.
All right. Let's see. Next question here. There's lots of questions. Thanks for keeping it. Now it's getting tough to manage. All right, but we like it that way. Thank you. Let's see. Is Oh, can we provide any links or any information about how Gurobi runs any pre-solve? Is there any documentation or anything there to help people understand, maybe you want to turn it off or certain parameters to mess with within that?
The way I read the question, they're saying any links about how Gurobi runs pre-solve. I mean, we see some of this in the Gurobi log, but if I'm not sure if they're asking about what exactly we're doing. I would say there actually is a paper that some of the Gurobi developers wrote where if you want to know like what's happening under the hood in pre-solve, this is one of the algorithm components of Gurobi we kind of published something that actually outlines like really specifically a lot of the different things that are happening. I can see if I can dig up a quick link for that and post it in the chat.
Okay, cool. All right. Let's see. What role does computational efficiency play in solving model with large data sets? Are there any approximations, reformulations, or parallel computing techniques that could reduce the runtime while maintaining accuracy? Is this I'm assuming that this may be with respect to the regression example. Does that seem that seems to be the case? You said this model. any reformulations or parallel computing techniques? I mean, we kind of did a reformulation within the notebook. If you're talking about the nonlinear regression example, where we wrote something that started out as a purely nonlinear equation with a a quotient of decision variables, and we rewrote it as a quadratic, or what would the solver would interpret as a quadratic, which again, quadratic is always better than purely nonlinear. Well, I won't say always, but typically better than nonlinear. So you'd want to go with something that has a formulation like that. So that was one example. And I'm not sure if there's anything for that particular example else that we could have done to make it run a little bit faster in terms of like parallelization and things like that's, that's all sort of under the hood stuff that uh, that can be helped out. I don't know. Dan, is there anything about that you would think that any parameters or anything that you can set to make something like that run faster, or anything that you would sort of see that would signify any problems?
And sorry, I was kind of looking up that paper. Could you refresh me on just exactly what the question was
Uh,
there?
so with the nonlinear regression example,
Yes.
there was a question about like, hey, is there anything we can do reformulation wise? And sort of hinted at the,
Mhm.
taking the nonlinear quotient part of it and rewriting it as a quadratic.
Oh
But
yeah. Mhm.
is there anything about like, just maybe in general about parallelization within Gurobi or something like that that would help in, sort of any best practices as well? I'm sure people would be interested in that. Anything that we can do to help sort of model solve faster in that aspect.
Right. Yeah. So I think in that for that example, reformulating it as a quadratic is generally a good idea. And I think a lot of this, it's in some cases, it's more an art than a science in terms of how to reformulate your model. In many cases, if there's multiple different alternate formulations, it's best to just try all of them. Of course, generally, if you're reducing the amount of nonlinearity, that's good. Regarding parallelization, I mean, Gurobi is running in parallel. This is managed by Gurobi under the hood. So if you give it more cores, it's going to use them to, parallelize the search through, as it does, say, a branch and bound tree. So there's not much you need to, I guess, worry about in terms of setting parameters other than just, making some processors available for Gurobi to run on. Although I'll mention that, as you increase the number of cores available, you're not going to see like a linear increase in the efficiency of the, method. There's a bit of a tailing off as you add more and more threads.
Okay. Another question is when we have problems that include probability functions as constraints, what is the best way to model? Should we build a table with probability values for each value of the variable, or or build a nonlinear model? So I think essentially the advantage of discretizing something like that versus just you're using a pure representation of some probability function that's obviously going to be complex and nonlinear. I don't I that probably comes down to I'll give my 2 cents and then hand it off is how accurate would you like to be, if you're okay, it's sort of the same idea as piecewise linear versus using something purely nonlinear. Are you willing to accept a little bit less accuracy for computational time? There's that trade-off as well. So I don't know if there's anything else that either of you would want to add to that.
Yeah, I guess I can just comment that I think this is a great question. This is something that a lot of people have been thinking about. A lot of people have looked at different types of approaches for handling uncertainty. I mean, there's an idea of robust optimization where people are usually maybe optimizing sort of toward the, you know, optimizing what would happen in the worst case scenario. Then there's other cases where people are maybe trying to optimize with respect to some kind of average case scenario where they might do something like take samples from the probability distribution to create many different scenarios and then try to make some high level decisions that are going to, on average, do well across all the scenarios. Um, and then other kinds of approaches where people look at, maybe wanting a certain percentage of the constraints to be satisfied. So I think there's kind of a wide academic literature of different ways to approach uncertainty.
Mhm.
And I think what's best might just depend on what you're trying to do, what makes sense, and what's kind of tractable for your particular case. because a lot of these are, solving these types of models, it adds some layer of complexity. It makes them more challenging.
Exactly, yeah. And stay tuned tomorrow for a session on practical ways to handle uncertainty, where we get into not so much the robust optimization and because that is pretty complex type of stuff, but easier ways to incorporate some of those uncertainty measures or uncertainty into your optimization model. So hang on till tomorrow, and we'll sort of dive into that a little bit more. Next question is, what is the best way to include a neural network as part of an objective function in Gurobi? I'll start with this one, and it's something I mentioned, I think it might have been last year in Opti 201, but we have an open source package, and I'll talk about this a little bit later in the day tomorrow. An open source package called Gurobi Machine Learning. And essentially, what that allows you to do is you take a trained regression model, and it could be something like an XGBoost, decision trees, random forest, a bunch of different things in scikit-learn, neural networks in like TensorFlow, and a whole bunch of different ways that you can build a regression machine learning model. And with just a couple lines of code, essentially just one line, you can say, take this um, trained trained regressor and put it into my optimization model. And what Gurobi does behind the scenes, or this package does behind the scenes, does all the linearizing, does all of the translating from that model representation to something that to all the constraints and additional auxiliary variables and everything, and puts that into an optimization model. So you can do that as your objective function. And we actually have a couple examples in the documentation on that website, and one of which um, is approximating a function using neural networks. So you have a bunch of data points that represent, that represent your complex sort of really wavy surface, and you use a neural network to approximate it, and you want to find the global min or global max of that. Um, and that essentially will help you find the min or max of the neural network that you're interested in. So highly recommend looking into that package. We'll have documentation about it, and so I'll talk about it briefly tomorrow. If you need any more help finding it, but again, it's called Gurobi Machine Learning. You can find it on our GitHub as well, and you can see the documentation there. Let's see. I have a request processing MIP that assigns who works a request and in what order given different request priorities. We're looking at incorporating neural network prediction that will incorporate high likelihood requests with models given the model's confidence. What are the dangers you can see with this approach, and do you think it's still worth pursuing if it's roughly 75% accurate? When it comes to, is this worth pursuing? Again, it's always the trade-off of what you're willing to accept for how bad is a how bad is a false positive? How bad is it when your model gets something wrong? If it's catastrophic, then if it's not, okay, it all depends on the the amount of risk that you're willing to accept given an incorrect decision that's made based off of an incorrect classification. So uh, that's always the trade-off in these problems. So I would suggest really diving into what happens if your neural network gets something wrong and has a wrong classification. What are the ramifications for your actual business problem that you're trying to represent? And if those are significant, then keep that in mind, and maybe there's ways to sort of build more robustness around it. And you add in like, hey, I want to make sure that have chance constraints per se or something like that, or something along those lines. But yeah, I would say that's the main thing to keep in mind is what is your trade-off? I don't know if either of you guys have anything else you want to add to that.
No, I think that's a good answer. And yeah, I think part of it is I know from a solution standpoint, like are we able to handle the neural networks? I think we've seen cases with some customers having performance issues with these where I mean it can depend on the size of the network. So sometimes people have these humongous networks they're trying to add to the model and it's creating billions of variables and then somehow then that doesn't work. So I think that's also you know consideration.
Yeah, yeah, it's a very good point. It's something I didn't really mention before is yeah, when you're translating these trained regression models into an optimization model, like you are obviously you need to add constraints, you need to add variables to represent that relationship. And if you have a massive neural network, you're going to have to add a massive amount of decision variables and constraints to your optimization model. So again, so just the same of you, are you willing to accept more risk or the risk of your neural network being wrong? Are you also willing to accept the trade-off of performance for accuracy as well? Because like if you whittle down your neural network to be something that is more performant in the optimization spot of it, you're going to probably then lose accuracy in your neural network. So again, there's always a trade-off, always a trade-off. Um, for large scale nonlinear optimization models, do you recommend any decomposition techniques um, such as Bender's or Danzig-Wolf decomposition that work well with Gurobi's solver architecture? I'll sort of hand that over to not.
Um, yeah, I think, you know, I think a lot of this would really be problem specific. What, you know, whether it makes sense to reformulate something or use a Danzig-Wolf kind of decomposition. I guess for some nonlinear problems, I mean, I think this, of course, this adds another layer of difficulty. Um, I think within Gurobi, if you're trying to do this with integer variables as well, this can also cause some challenges with, you know, with Gurobi, you have the power to add variables and re-optimize and add constraints, but we don't allow you full control over controlling the branching decisions. So if you're trying to do a branch and price, this is something you would need to implement some of those things on your own. But yeah, I mean, we've seen people use Bender's decompositions, Danzig-Wolf decompositions for various things, and I think also involving some things with nonlinearities.
Let's see. What are the most important implemented techniques in Gurobi that solve nonlinear problems? Are any of those boosted by graph neural networks in any way?
So I can just give maybe just some high level ideas of what some of the algorithms are. I mean, so for solving the continuous relaxations, you know, we have this kind of barrier method to solve certain forms of quadratic problems, and for linear and also some simplex for certain quadratic programs, convex quadratic programs, and for linear programs, of course. For the nonlinear models, a lot of it's done through outer approximation, linear outer approximation. So basically, we take these nonlinear functions, we form linear outer approximations, and then we apply as again a sort of branch and bound algorithm where we may also branch on continuous variables to sort of chop up those nonlinear functions into smaller pieces, and all the smaller pieces we can then approximate better with linear outer approximations and kind of repeating this iteratively until we're able to, you know, find a solution that satisfies the level of accuracy, you know, by us doing these tighter and tighter outer approximations, and then also satisfies the, you know, optimality requirements. So in some sense, under the hood, we're actually reusing a lot of the MIP technology to solve these nonlinear, you know, mixed integer nonlinear problems. And this is, I would say, also our development team has been working on this a lot, and this is going to be a continued push to sort of improve the functionality, improve the performance on various kinds of nonlinear models.
Mhm. Great. And as a just a quick reminder, if I see sort of some questions and stuff popped up in the Zoom Q&A, if you could put those over into the Hoover, that's what we're sort of all looking at. In and so just quick copy paste over there would be very helpful as we're finishing up these questions and everything. So let's see. Um, will will there be any examples of Gurobi machine learning shown tomorrow? How much overlap will there be with the nonlinear course we just with the nonlinear content we just saw? We're not going to be diving into Gurobi machine learning in too much depth tomorrow. Um, we have done some webinars on it, and it's been mentioned. So we do have some other resources plus the documentation. Um, so if you're interested in learning more, you can definitely find those resources on our website to get a little bit more information on that. But I will say that one of the issues with that using that package pre Gurobi 12 or actually even pre 11 um, when we started solving nonlinear stuff directly there was a lot of piecewise representation of because even though I was talking about regression problems, you can use logistic regression, which is obviously used for classification, but it is, you are still outputting a continuous, you have a continuous output. But there was some approximation of that using piecewise linear, just, not so long ago, but now with Gurobi 12 having sort of significant improvements in solving nonlinear problems, then that type of relationship is now directly handled in Gurobi machine learning. So there's some improvement there. As for what we're going to be doing the rest of tomorrow, not diving into that too much. I don't want to give too many spoilers, even though we're still in the middle of Opti 202. Opti 301 is in my head, thinking of what we're going to be doing, and I think if you're interested in more of that, I think Opti 301 will have more on Gurobi machine learning, given the significant improvements that our R&D team has had this year, and particularly what is planned for the next year as well in solving nonlinear problems. So more to come on that, I'll say. Let's see. In the regression example today, the data was read in Pandas data frame and then transformed into GurobiPy multidict. Is there a benefit to doing that in comparison to just using GurobiPy pandas? Um, I guess I don't, particularly for that problem, very little difference, if at all, because it was so small. I will say that that using sort of native Gurobi Pi sort of functionality for something like a multi-dictionary is always sort of like the best way to go. Um, at least that's what I've been told by our experts and everything. And so I would suggest doing that as well. And it is just a very convenient way to sort of um, um, build the bits and pieces you need of the optimization model pretty quickly. Honestly, it could have been handled a bunch of different ways. Just so happened to be that way. And you mentioned Gurobi Pi pandas. Again, that is another open source package that Gurobi has put out there, that helps you if you're a pandas thinker, if you work with data and you group by everything and do all that sort of stuff, then using Gurobi Pi pandas is a great way to essentially just work and develop your model, work with it, build constraints, and import and export, import data, export the solution, all using series and data frames quite easily. So it is a nice way to sort of keep that pandas frame of mind while using optimization modeling. So again, another great open source package to help with optimization. And the question is it better to use like a multi-dict or Gurobi Pi pandas? Um, it depends case by case, I would say. I don't know, Dan, if you've worked too much with that package, if you have anything to add on to that, or if customers have and have any anything to say.
Yeah, I think you're right that for this small example where we're basically just pulling in some data and just then putting that data in the model, this, this worked just fine. The Gurobi Pandas package just has some more extended functionality. I think it like makes it convenient to do things like maybe store your Gurobi variables inside of the data frame and operate on them in certain ways. So I think, if you're a big Pandas user, you might check out our documentation or one of the webinars about the Gurobi Pi Pandas package to see if if you want that extra functionality that it offers.
Mhm. And if you want to see a little bit of a sort of tutorial on through an example of the Gurobi machine learning package while using a little bit of the Gurobi PyPandas package, there's an example in our Jupyter Notebook modeling set of examples called the avocado price optimization example. And that one has both of those used in one notebook. So there's a couple different versions of that notebook. The first one you'll see is just using sort of hard coding a least squares regression model that uses historical data to essentially model the price demand relationship between the price of avocados and the demand over different regions. And then in another version, we sort of replace that ordinary least squares model with a with a trained regressor. And we sort of go through a couple different of those. Say, okay, what if we keep it as a linear regression model? What if we use a random forest? What happens? Sort of how does that change what your optimization sort of problem looks like from a size perspective, but also it does change the results based off of how you interpret that relationship. And then there's also another version of it if you have access to a full license where we sort of dive into it again and again. Licenses are free for academics and everything. You can dive into like a full example where there's sort of really sort of let the regression model explode the optimization model a little bit to get that sort of fine-tune accuracy in the regression model, and then sort of see how that plays out through the optimization as well. And so you can sort of see how that whole thing comes together through that example. What I can do is while I'm here, I'll just see if I can find it real fast. And because it's probably my favorite example that we've come up with. I'll put that in the Whova chat here. So check out the chat, and I put a link to the avocado price optimization. You'll see several of those examples that I just talked about. And also did another price optimization one, which is a little bit more of a simple problem of competing products, which doesn't get into the Gurobi Pi Pandas thing as much, but it does use the Gurobi machine learning again. So both of those are in the Whova chat for this session, and you can dive into those. So I think that's all of our questions. I don't see any more that are marked as unanswered. So last call. If you have any questions, throw them in the next minute or so, and we can get to them. I don't know. While we're waiting for that, I'll go around the horn. If there's any parting shots that everyone wants to give, go for it. Dan, you have any last minute advice for people?
Oh, last minute advice. I don't know. Well, we covered a lot of stuff. I mean, I guess one thing I would say is that, for continued learning, you can check out our Gurobi webinars, and recordings of previous webinars contain tons of, good content showing how to use our product and giving you background and optimization. And also to highlight that we have, for commercial users, make use of our support. You can open tickets with us. We can help answer your questions about all kinds of topics. And for academics, we have a very active community forum where people can go ask their questions and have discussions about really everything related to Gurobi and optimization.
Yeah. And not to spoil the end of one like the wrap up session, but essentially at that point, I sort of concede that like, hey, we've been through a lot in the Opti series. So yeah, it's if you haven't started checking out like our very technical webinars and all of that content, um, then yeah, it's time to start hopping into that. So Hassan, do you have any last minute thoughts, advice?
No, I mean, you and Dan both covered it. I would say, you know, the documentation itself has a lot of stuff like inside of Gurobi. Like if you go to the website, there's so many materials there. There are courses. Gurobi has created even a course with, Georgia Tech. So that's a great course. I even watched it to see if I can steal some of the material for some of the other engagements that I have. So it's a lot of materials there from beginner to intermediate to advanced. Yeah, definitely check them out. And of course, if you're in doubt, just Google it and you will be directed to some links, again, even the Gurobi support website in many cases, and you will see a lot of good examples, more complicated examples come up. So yeah, that's always my go-to.
Awesome. All right. Well, I think that's it for the questions. So I think we can probably wrap up now. And so thank you everyone for tuning in. And I'll see you all tomorrow for starting off with Hassan again. So enjoy the rest of your day, and I'll see you tomorrow.